Hello everyone. So last time, pinag-usapan natin yung single cash flow scenario, yung pagkuha ng present value as well as the future value of that single cash flow scenario. So this time around, pag-uusapan na natin yung multiple cash flow scenario. So in particular, ang pag-uusapan natin today is all about irregular cash flows. So gagawa tayo ngayon ng cash flow diagram. So this is time 0, year 1, year 2, year 3 hanggang year end. So halimbawa, may mga cash flows tayo on this period. So we have this cash flow at year 1. Denote na lang natin siyang A sub 1. At year 2, so we have another cash flow. Then year 3, we have another cash flow here, and so on. So itong mga cash flows natin ay hindi equal. So it can be the case that A sub 1 is not equal to A sub 2, is not equal to A sub 3, is not equal to up until A sub n. So kaya siya tinawag na irregular cash flow. So paano kukunin yung present value as well as the future value of these kinds of scenario? So yan yung pag-uusapan natin today. So we have these cash flow diagrams here. So mangyayari, itong A sub 1, in particular, para makuha natin yung present value niya, ay idadala natin ito papunta sa year 0, the present time. So ganun yung gagawin natin sa lahat ng cash flows na nag-occur all throughout our period. So A sub 2, ganun din. Dadala natin siya sa year 0. A sub 3, idadala ulit natin siya sa year 0. And A sub n, the same case, idadala ulit natin siya sa year 0. So yan yung ating magiging working diagram sa pagkuha ng present value ng multiple irregular cash flows. Pero paano natin yan i-compute? So as mentioned last time, gamitin lang natin yung annotation natin. The present value is denoted by P. Our cash flows is given by this formula. So A sub 1 times 1 plus I raised to negative 1. By the way, so hindi nabanggit kanina, our interest rate here is I% and N periods. Okay. Plus A sub 2 times 1 plus I raised to negative 2 plus up until A sub n times 1 plus I raised to negative n. Paano ba itong nag-work itong formula na to? So, say for example, itong first term natin, we have A sub 1 times 1 plus I raised to negative 1. Bakit naging ganyan? No? So, we can get the present value of this A sub 1 by simply multiplying the original cash flow, A sub 1, by 1 plus I raised to negative 1. So, saan nanggaling yung formula na to? Tandaan itong 1 plus I, this is just simply the growth rate or the discount rate, depende kung kinuha natin yung present value or future value. So kapag raised to a negative number, so discounting ang nangyayari dito. Itong negative 1, this is just simply the difference between 0 and 1. So 0 minus 1 and so on. So sa A sub 2, yung exponent ng 1 plus I is 0 minus 2. So that is negative 2 and so on hanggang sa nth cash flow. So ang exponent ngayon ng kasama ni A sub n, si 1 plus I ay 0 minus n. So we have this one, negative n. So in summation notation, the summation from t equals 0 to n of A sub t is 1 plus I raised to negative. So how about future value? Sa pagkuha naman ng future value, so mag-drawing ulit tayo ng another cash flow diagram na similar to that. So we have a cash flow here, here, and over here. So A sub n. So cash flow here is A sub 1, this is A sub 2. This is A sub 3. So this should be A sub n. Okay. Paano ang working diagram naman natin dito? Itong mga cash flows na to ay kailangan natin kunin ang kanilang future value at say for example time n. Lahat ng cash flows na ito ay dadalhin natin dito sa time n. A sub 2 sa time n din natin siya idadala. A sub 3 ay sa time n din natin siya idadala. Meanwhile, A sub n ay nag-occur na talaga siya sa time n. How do we find the future value of these cash flows mathematically? So we have this formula, no? A sub 1 times 1 plus I raised to n minus 1. Saan ang galing yung exponent na n minus 1? So, bibilangin lang natin yung number of periods in between 1 and n, and that is n minus 1. And then a sub 2 times 1 plus I raised to n minus 2, and so on up until umabot siya sa a sub n 1 plus I raised to n minus n, or just simply 0. Okay. So in summation notation, so paano ito in summation notation? So we have the summation from t equals 0 to n of a sub t times 1 plus I raised to n minus t. So, yan lang yung ating working formula. Okay, so may napansin lang tayo. So, some corrections before we proceed. So, itong a sub 2 should be cash outflow. So, baka malito lang tayo later on. So, this should be, instead na plus, this should be minus. So, ganito din dito. So, a sub 2 ay cash outflow. So, instead na plus, this should be minus. Okay. Okay, so we proceed to solving the first problem. So we have this problem here. If you invest $2,000 today, withdraw $1,000 in 3 years, deposit $3,000 in 5 years, and deposit another $1,500 in 8 years, and withdraw the entire sum 3 years after the final deposit, how much will you withdraw? Interest is 7%. Paano natin isa-solve yung ganitong klaseng problem? Una, our given is that our interest rate is 7%. So, this is 7% per year. Hindi naman sinabi na annually or monthly. So, we should assume that this is an annual interest. Una is gawa tayo ng cash flow diagram. So, we have this cash flow diagram here. This is year 0. So, if you invest $2,000 today, so you have invested $2,000 sa iyong account. So, meron ka ditong 2,000. And year 1, year 2, year 3. This is year 3. You withdrawn $1,000 in 3 years. So meron kang withdrawal na $1,000. And nag-deposit ka ulit sa year 5 ng 3,000. And another deposit on year 8 na 1,500. And withdraw the entire sum 3 years after the final deposit. So 3 years after the final deposit, that is year 11. So nandito na yung i-withdraw natin, yung total sum. No? Sabihin natin this is the future value. Okay? Ang tanong sa atin, how much will you be able to withdraw? So magkano itong value ni F? So at interest rate of 7%. So, ang approach dito is that every cash flow na nag-occur on that period, dadalhin natin papunta sa future. So, halimbawa ito. So, this one, dalhin natin sa year 11 yan. Ito naman, 3,000, dadalhin din natin yan sa year 11. And yung 1,500, dadalhin din natin ito sa year 11. As well as this $1,000 na withdrawal. So, mathematically, so we have 2,000 times 1 plus I. So, I is 7% or 0.07. So, mas madali na i-denote na lang siya as 1.07 raised to what? So, ilang years ang lilipas para makapunta ka sa future time from the present time. So, that is 11. So, raised to 11 minus itong ating withdrawal na 1,000. So, that is 1,000 times 1.07. Again, from this year around, so year 3 hanggang year 11, ilang yung time period niya in between. So, that is 11 minus 3. That is 8. No? Yan. So, plus 3,000. So, this 3,000 occurs at year 5. So, ilan yung time period na lumipas from year 5 going to year 11? That is 11 minus 5 is simply equal to 6. And lastly, we have 1,500 na nag-occur noong year 8. So, ilan yung time period na lilipas from year 8 going to year 11? That is 11 minus 8 is equal to 3. So, yan. Then, i-plug natin lahat ito sa calculator para ma-compute natin yung values. So, okay. 2,000 times 1.07 raised to 11. Okay. Minus 1,000 times 1.07 raised to 8. Okay. Plus 3,000 times 1.07 raised to 6. Lastly, we have 1,500 times 1.07 raised to 3. Okay. So, and then enter. So, we have this amount, 8,831.27. Okay. You will be able to withdraw an amount of 8,831.27. So, ito yung value ng ating pera, ng iyong deposit after withdrawing the entire sum, no, on 3 years after this deposit. Okay, so ngayon naman i-apply natin ang formula ng multiple irregular cash flow. So we have this problem here. So you can pause the video and read and understand the problem. Our main goal here is to determine which of the two ways ng pagbabayad sa machine ang best sa manager. So the first scenario is that magbabayad siya ng ngayon ng full price less a 3% discount. So the full price is $30,000. Ilan? So 97% na lang nung kanyang full price. So that is equivalent to 30,000 times 0.97. So, $29,100. So, ang babayaran nyo na lang dito sa first scenario ay $29,100. Ngayon, yung second choice niya is magbayad siya ng $5,000 now, $8,000 1 year from now, and then $6,000 at the end of the next 4 years. So, we have here, this is year 0, year 1, year 2, year 3, year 4, year 5, and year 6. Sabi dito, pay $5,000 now. So, may payment kang $5,000 ngayon. Then, $8,000 1 year from now. So, $8,000 here. And then, $6,000 at the end of each of the next 4 years. So $6,000 dito, another 6,000 dito, another 6,000 dito, and so ang gusto natin gawin dito is that lahat ng mga payments na ito ay kukunin natin lahat ng kanilang present values. So yung 8,000, idadala natin siya papunta sa year 0. Ganon din dito sa 2,000, sa 6,000 sa lahat ng mga succeeding years ng ating scenario dito. I-apply natin yung formula. So, kunin natin lahat yung present value ng mga cash flows on the different years. So, we have this one here. So, yung 5,000 peso, ay $5,000 ay nasa year 0 na. So, it can be written as this, 1.12, no? Dahil 12% compounded annually, raised to 0. Then, next, so that this is negative dahil nasa baba. Minus 8,000 times 1.12 is to 0 minus 1, or just simply negative 1, minus 6,000 times 1.12 is to negative 2, minus 6,000 minus 1.12 raised to negative 3. So, ito na yun dito. Minus another 6,000 times 1.12 raised to negative 4. Lastly, para sa year 5, minus 6,000 times 1.12 raised to negative 5. Okay, so i-plug natin lahat ito sa calculator and let's compute for this. Negative 5,000 u times 1.12 raised to 0. So, times 1 lang yun. So, minus 8,000 times 1.12 raised to negative 1 minus 6,000 times 1.12 raised to negative 2 minus 6,000 again times 1.12 raised to negative 3 minus another 6,000 times 1.12 raised to negative 4. And lastly, we have another 6,000 times 1.12 raised to negative 5. So we have here negative 28,414. Negative dahil outflow yung cash. So, but we can also write this as a positive number dahil pera naman ang pinag-uusapan. So, yung negative dito, yung direction lang nung cash. So, we have 28,414.37. So, 28,414.37 dollars. So, comparing the two, no, 29,100 yung mode 1 and 28,414.37 dollars naman sa mode 2. Best way for the manager to make the purchase is by using the second choice, no? Choose mode 2. So, yun lang yung application natin. So, see you sa next video.